friends, welcome to this world. This is the first episode in the math series. But wait, what's the math series? Yes, so we just discontinued the activity series. It was just boring and nothing was actually happening there. But now, math is here and we can learn some math. Yes, and my favorite subject is actually math. So, yeah, let's begin. What today's video is about conversion of decimal to fraction and fraction to decimal. Yes, so first let's just talk about the fraction to decimal conversion. So as we already know, a fraction is a by b, where a and b belong to integers, and along with that b cannot equal to 0. Yes, because division with 0 is absolutely impossible. Yes, so we don't get an answer because the answer does not exist. Yeah, okay, but let's begin. We already know the fractions. So let's take any fraction, a random fraction list. What should we take? Okay, let's take 49 by 4. Yes, so this is an improper fraction, 49 by 4. So what we should do is division. Take the numerator as the divider, the dividend, so 49, and 4 as the divisor, the small d, the big D. So 4. So we should practically do division. Okay. So 49, 4, 1 down, 9 remains. Okay. Now 4 8's 2. Okay. Now we got remainder of 0. But we need to convert it into a decimal, right? Not just an integer. Not a mixed fraction. So what we should do is add a 0 here, add a point here, add a decimal point there. So now divide by 8, 2, we'll get 2, 0. We should add 0 every time because it's impossible without adding another integer. Yes. So now 20. So we get a remainder of 0. So 5 4's 20. Yes, so we got the answer 12.25. So this is an improper fraction over here, but it also works for proper fraction as well. Yeah, it works for every type of fraction. If you want to do for mixed fractions, you just convert it into an improper fraction. Yes, so this is fraction to decimal. This is very simple. But what about decimal to fraction? Yes, so decimal to fraction is further subdivided into many categories on how we should do it. Yeah, so let's begin. I'll use another color for this. So first, there are just integers to fractions. Next, terminating decimals which eventually have an end. Next, there are non-recurring cannot exist. Yeah, okay, mixed recurring decimals, and finally pure recurring decimals. Yes, there are 4 main types. Non-recurring cannot exist because every non-recurring non-terminating decimal is practically irrational and it cannot be expressed in forms of fractions. Yes, so let's begin with the simplest of them all, the integral form. So take an integer. Let's take 8. So every integer is just the integer itself by 1. Yes, it's fractional form. 8 is equal to 8 by 1. This is the simplest of them all. A very simple explanation. Now let's take 2. It's just 2 by 1 or 5 by 1. Yes, so this is the very simplest of them all. Now we're going to go with terminating decimals. Okay, so let's take an example. Okay, 101.25. Yes, so but how should we make it a fraction? So how many numbers are in the decimal part? 1, 2. Now always add a 1 in front. So now remove the decimal part in the numerator. So now we got 125 by 100. Yes. So this is equal to 1.25. If you want to, you can further simplify it. Yes. So 25 we divide it by 25. So we'll get 5 by 4. Yes. So these are terminating decimals. These are also pretty simpler compared to the next ones we'll have. Yes. So wait. I kinda actually wrote this in the wrong order. Pure recurring decimals are a bit more easier than mixed recurring decimals. But okay, let's start with pure recurring decimals. So let's take a pure recurring decimals such as 0.3 and bar. So bar means, if you don't know, it just goes on forever. 3, 3, 3, 3, 3. So to simplify everything, we just write bar. Yes. So these are pure recurring decimals. That means they don't have any non-recurring part in the decimal part. Yes. So let's begin. So how many? So first put it in a fraction. Remove the in front 0. So how many numbers are in the decimal part? 3. I mean 1. So we should add 9. So which we can simplify to 1 by 3. And as 0.3 bar is equal to 1 by 3. So this is correct. This is how we can convert pure recurring decimals into fractions. Yes. So this is also pretty simple. I'll also give another example. What should we give? Yeah. 0.1 bar. No. 0.2 bar. Yes. Now let's see what's the answer for this. So 2 by 9, which is, it's just 2 by 9. That's it. Yes. So there is just one number here, one repeating number. So we just add how many recurring numbers are there by how. Wait, I'll explain. So how many how many integers are just in the decimal part that are recurring? Here it is 1. So we add that many number of 9s. So which is also 1. Yes. So for other examples, we can, like it depends on which example you're taking. For example, you're taking 0.34 bar. Then you could do 34 by 99. Yes. So because there are two numbers which are recurring and two nines to be equivalent, to be correct. Yes. So, but what if this is not just 0? There's a whole number here, like 2.34. These still count as pure recurring decimals, even though there's a whole number in front. Because what matters is the decimal part, not the whole number part. We just ignore the 2. We now make it a mixed fraction. Simple. It's not that hard. Yes. So now, last and finally, let's go to everything's destroyer, mixed recurring fractions. These are a bit more harder. So let's take an example. Okay, let's take 0.74546 and 56 are bar. Yes. So wait, I'll just make it simpler. Sorry. Okay, now, we'll try the before example later, because this is just for practice to show you how it works. Yes. So we remove the 0, we remove the bar, we add 99. But 7 is of course not recurring, right? What should we do to that? We subtract the 7 from it. So now we get 69 by 99, which is the answer for this question. Yes, or just basically 23 by 33. Yes, so 0.766 bar is equal to 23 by 33. Yes, only the 6 is in the bar, 7 is not in the bar. Yes, so this is very simple, even more simpler than before. Wait, let's just take the before example. 7, 4, 5, 6. 5, 6 are under the bar. Now we remove the bar with 0. Now we remove the bar and the 0. We now do 9, 9, 9, 9. Subtract the 74. We do some bit subtraction. Yeah, simple subtraction. 8. So we get 7382 by 9999. 7382 by 9999. Yes. So this is how we convert mixed recurring decimals into fractions. And of course, if it's like, so 2.7456. Now let's take 7.7456. Then we do the same process, but at the last we add the 7 as a mixed fraction in the front, the whole number part of the mixed fraction. Yeah, it's that simple. These are not so hard. Like, wait, what if I gave you a worksheet? Would you try a worksheet? Wait, I'll try it next video. So yeah, this for today about converting fractions into decimals and decimals into fractions. So bye.